Yep. Did anybody try about installing WordPress? No one?
Yes, it worked for me.
Yeah, right.
Okay. Any difficulty? Anything? Any problem you faced? Or it was smooth?
Was okay. Yeah.
Because I want, like, if you are not from administration background, at least you should be some confidence, some happiness you get if you can quickly install your own WordPress blog, right? You can write a blog and you can host it yourself instead of asking somebody else to host it for you. And you can create your own domain. You would, create your own domain name, like register your own domain and create your own service somewhere on cloud or maybe in your home itself. You create a VM, install a Linux VM, create a Linux VM, and expose it to the to your GoDaddy maybe, and that you can host your own server in your own home also, and write your own blog. So that was the intention. Even if you are not going to be an admin yourself in your career, but just it will give a confidence of something creating your own, right? So that was my intention also. But well, let's see in the cloud, if you are going to create an application, as we discussed last time. Okay, here it is about my creating a resilient architecture. Okay, that means if I create one architecture on cloud, how to architect the application so that it will be resilient, and that is part of the reliability pillar, because we briefly, I think we discussed about the well-architected framework on AWS. And I think I also showed you that PDF file, which completely talks about what is the well-architected framework on any cloud. In fact, that will be valid on any cloud, not only AWS. So one of the pillar is reliability, right? So how reliable your architecture is. In fact, like if your system fails, how to recover from that, right? So that is a part of the reliability pillar, and it is obviously part of the resilient architecture. And in fact, when your compute resources does not meet demand, suppose you are creating single instance or multiple instance, and the users were more and more, they keep you utilizing, your utilization is increasing day by day. And how to mitigate that kind of demand, how to meet that demand without yourself doing much, without any manual intervention, right? How to meet that demand. So reliability pillar discuss about the recoverability of the infrastructure as well as the scalability of the infrastructure, right? That means if it fails, how to recover from there. And if it does not meet the demand, that means obviously if it does not scale, the performance will be degraded of the system, right? So your application will not be able to meet the demand of the users. So that does not help for the business. So how to do that, right? So today's session kind of starting with the reliability pillar and how to make our application architecture highly reliable and highly resilient with the help of some of the functions or some of the services provided by AWS. One of them is load balancer. So we call it, AWS call it ELB, Elastic Load Balancer. That means the load balancer is quite elastic. You don't have to size it. So it depends upon the demand, it will increase. It should not be again one single point of failure, right? Because whole traffic will travel through that load balancer. That means it should be elastic. Even if you can create your own load balancer, there are a lot of load balancers available in the open source market. One of them is HA Proxy, right? And there are other load balancers like Nginx. So even if you don't want to use, you can create your own load balancer, but whether it will be scalable based on the demand, may not be. But what AWS gives is highly elastic. That means you don't have to manage it. You don't have to uh, design that how big it should be. Once you create a ELB, it will be scaled and it will all your traffic will be taken care of. So that's why they call it elastic load balancer. Let's see what is the load balance. How many types of load balancers are there? Okay, so I hope you can see my screen, right? Just to check.
Yes.
Okay, so so these are the three types of elastic or load balancer AWS gives. And one is the application load balancer, second is the network load balancer, third is the classic. That means it's a bit old classic load balancer, which people don't use normally. But there are some elastic, like classic instances are there, previous generation of instances. They work with classic load balancer, so still they are providing that. But mostly people use today the first one, application load balancer, and the network load balancer. So what is the application load balancer? It is actually a layer 7 load balancer. It works on the layer 7. If you know the TCP IP layer, the 7-layer system of the network 7-layer, right, system. So this application load balancer works in the top layer, in the application layer, that they call layer 7. Whereas the network load balancer works at the network layer, that is the layer 4, right, and the connection level. So these are the first of all technical difference, which layer they work. And normally most of the applications, web-based applications, your application load balancer will suffice. But where you need really a fast load balancer and ultra million requests, like handling millions of requests and ultra low latencies is required and paramount, then people go for network load balancer rather than the layer 7. But if you want to load balance your some applications like containers, right, or Docker containers or microservices, you want to create a microservice based on a container, there mostly application load balancer will be useful, because though there are containers, but containers run on the application layers, and because it has in the, you know, it just works with a IP address and port. So sometimes you work with microservices, you expose your service through a service layer. We'll see more about it once we talk about Docker container. But if it is a Docker container based microservices, it should be application load balancer should be used, okay? Because it's not instance level. And if it is instance level, then either one you can use, application load balancer or network load balancer. I'll not talk much about classic load balancer. It is there just to serve the old classic EC2 instances, okay? So these are the three. Let's move ahead, and this is typical architecture of a load balancer. So we have two instances, if you see two availability zones in a region. Yeah. Okay. So the user reaches to the public internet, and it reaches to the internet gateway and the ELB. Then it hits the load balancer. And there can be a security, there is a security group attached to the ELB also. And after that, the ELB decides how to send the traffic to which instance. It can be instance level, or it can be if it is cross zone enabled, it will go to different zones also. So based on the, you can select on what basis your traffic will be divided. You can do that while configuration. Okay, so there are, I'll first finish the theory part. So there are some advanced techniques are there. So like one is the sticky sessions. Okay, so this is when this is typical network architecture, but let's go to some of the functionality it gives. Elastic load balancer, the application developers must have already familiar with the sticky session management, right? In Java, HTML, and all those session codes, right? How do you manage sessions? I used to do that when I was a Java developer. I used to do like 15-20 years back, how to manage the sessions. People used to ask in the interview, right? So using cookies and all. So what is sticky sessions, by the way? Like I'm a user, I'm accessing some of my personal data, and suppose EC2, maybe this is let it be 1, and this is 1, and this is 2, suppose EC2 1, and this is EC2 2. So this is 1, and this is let it be 2. So here, suppose a user 1, this is user 1, I just quickly made it user 1, and this is user 2, right? So suppose user 1 is browsing and he has a session associated with a particular EC2 instance. It is serving. Suppose this is the one, this EC2 1, it is serving user 1, and EC2 is serving user 2, suppose. Without sticky session enabled at the load balance level, what we'll do is this traffic will go always obviously to different instances based on the availability, based on the load of the each instance. Then session is actually not managed by the load balancer. Then what you have to do, either you have to balance it through your own application, that then it becomes tedious because the developer has to take care of the session, right? So that it becomes a developer level work. Whereas that means user 1 is sometimes it is engaged with EC2, sometimes it is engaged with EC2 based on the traffic and the load of the each instance when sticky session is disabled. But when sticky session is enabled, that means suppose EC user 1 is handled by this particular instance, okay? EC1 instance, it will remain as it is. That means till the end of the session, it will be only served by, always the traffic will be sent to the same instance which is serving the user 1. Okay, so user 1 logged in and he's still there up to the end of the session. Okay, once the user closes the session, then only it may be traveling to other instances, but as long as the session is active, it will be traffic always will be sent to EC1. And same thing with user 2 is, suppose another user is attached with user EC2, that time the session will be active only in user 2, so that the developer does not have to take care of the session management. That's one advantage. Another thing is cross-zone load balancing. So here, let's see. Suppose this is availability zone A. By the way, I took these pictures from Amazon website. So this is a declaration for the page. This is not my own picture. This is I took from Amazon website. So because I was quickly making this today, I didn't have time to make my own. I just copied it. Okay. So let's see. Suppose the user logged in here, and this is the two ELBs which is not cross-zone enabled. Okay. So what happens here? You see the load is divided by 50-50 here, 50% and 50%. And here there are, suppose in availability zone B, there are 1 to 8 instances are there. Then that 50% is going to be divided by the 8 instance. Whereas here, it will be 2 instances are serving, so it will be 25%. So that means if you see, this is each instance is loaded with 6.25% of the load, and this is 25% of the load. So there is something unbalanced, right? But here, if it is cross zone is enabled, irrespective of which zone the instance is, the traffic will be the same to each instance. This is what when the cross zone load balancing is enabled. We'll see that in practice, how to do that, okay? Another thing is path-based routing. So with, suppose our application has, just an example, there can be many much more way to explain this, but here you have a web application, let it be the WordPress application, and there are the English way of serving. Suppose your web application should serve to English speaking people, and maybe native language also you want to serve, or maybe Spanish here. So you can go like pnayak.com or bigopencloud.com/en, then it will, if the path is defined as that, all serving pages will be English, and /es, suppose here I have given, if the browser is given this particular path, then the Spanish language pages should be given. So that one can be configured at the ELB level also. So that is called path-based routing. So we'll see that also. And this is another use of this is, if it is microservices, let it be, these are the EC2, suppose this is microservices, which again API based, right? Mostly. So /user maybe, or /login, or maybe this is a, suppose this is a microservices which is serving for your cart, another is for your price, right? Or then you can have different microservices configured. The path, API path can be different here, and that will be serviced by different microservices. And this one path will be serviced by different set of microservices. That is also possible using path-based routing, okay? So with that, these are some of the important aspects of configuration of ELB, but this is mainly ELBs are used for taking care of and load balancing different instances and different services, different containers, and also sometimes it is also used for high availability. Like if one instance goes down, other one also can be servicing that. So two things it does. It does the load balancing as well as the high availability. So let's see how we can achieve both. Today we'll see both high availability as well as load balancing. Let's log into our AWS. So EC2, I'll go to EC2 instance, and let's create a small web server. Okay, quickly we'll create a web server. So here, how many participants now? Okay. So by the way, I just in between, I thought I was waiting for my wife to join. So it is her birthday today. So I didn't want to continue. I thought of actually not doing the session today because I wanted to have, but it is Tanmay Das here.
Happy birthday to her.
Happy birthday.
Thank you.
Yeah. So, and by the way, who does not know, she's my wife.
We know.
So she's attending all the sessions. You might, people might.
What do kids do when you both attend the sessions?
Happy birthday, Tanmay.
Thank you.
So, well, that's why today's session will be like
Short.
shorter. So I'll just go quickly. Yep. So, well, Just wanted to let everyone know. So let's go and start a web server now. I'll launch the instance. Select and T2 micro, and here I'll create a public subnet into A, and so I saw this is subnet settings. Let's create a web server. I want you should do it instead of logging in directly. We can do it here, right? I will create a script here. We can do that, right?
Class இருக்கு பாப்பாவுக்கு நீ பாரு
Mute, please. Let me.
Okay. Okay.
Okay, thank you.
I'm sorry, Panklesha, that's from me.
That's fine.
Sorry, just took my headphone. You just hear that you said happy birthday, right? So somewhat he understood that and he wanted to wish. He was just taking the headset and he was just started talking something.
No, that's he was cute. So it was good, cute boys. Okay, so this is what. How can I create a web server? This is also a good way to learn. So here, then yum update -y yum install httpd -y, then systemctl start httpd systemctl enable httpd cd where then echo maybe this is web server 1 or server 1, and do this is HTML h1 and I'll give it to index.html. Okay. You think it will work? So that's what I just quickly explain what I'm doing. I'm updating the packages, then I'm installing the HTTPD package, and then I'm starting the service HTTPD using system control command. Then I'm enabling it, so with the restart it will start. And I'm going to this particular directory. Once HTTPD installed, this directory will be created actually. So I'm going there, and what I'm doing is I'm creating a file, index.html, and I'm writing in that HTML hello from web server 1, right? So let's copy this because we'll need it multiple times. So what I'm doing.
The double quote is not ended.
Oh yeah, right. Thanks. Okay. Okay. So let me. So okay. Copy. Hopefully it will work. If not, we'll have to recreate it. Okay. Hopefully it should work. Okay. So hard storage, 8 gigs would be fine for us, and add a tag, maybe name web server 1. Okay. Security group, I'll take an existing security group which allows my 80 and port and review and launch and launch. Okay, so let's create another one also. And you see this, let me check it first whether it's working or not, right? So if you see here, it is launched in this VPC and subnet is public 2A, right? So 2A availability zone, it is launched. Now, let me launch another instance just to show how the load balancer works. And what I'll do is I'll create in the 2B, which is public. Again, 2A it was launched now, and I'll enable IP address 2, and that's all. And I'll do it here. Let it be 2. Okay. So this is the same thing, but I changed hello from web server 2. Okay, so that we can distinguish where the traffic is coming from. Add storage, add tag. Server 2. Security group. I'll put the same security group. That means that 80 port will be allowed and launch the instance. So I launched 2 instances. One is availability zone 1 according to my picture here. The one this is AG1, right? So I launched an instance here and I launched another here. Both are public, and I attach the security group of which allows port 80, right? That's it. So web server 1 is, let's check if it is ready. So I took the IP address. Okay, it is ready. That means it is working, right? Hello from web server 1. So let's see if 2 is working. Still it has to. We need both to be running. So this is public subnet to A, and this is public subnet to B, right? And instance here is DMG web applied. So let's see. It's running. Let's see again. 54. Okay, we got it, right? We saw just to differentiate that which server it is coming, the traffic is coming from, right? So this is coming from the web server 1 and this is coming from the web server 2. You see? Now, these are the 2 servers serving same code, but different code, obviously. 2 separate servers. This is not the actual scenario. Both should be the same, right? Because it is one application. But just for the demo, how it works, I just created 2 separate. We'll show also how it is working, okay? So now, here, because of the Zoom, I am not able to do a full screen, so I have to do it. Now go down. Here, that is called load balancing section. Create a load balancer here, okay? So let's do that. Create a load balancer, and let's start with the classic, okay? Previous generation, how it is working. It's a very simple one. Application load balancer is a bit smarter. I'll tell how, but let's create a dumb load balancer. It does not know anything. It will simply forward the request. So I'll create this called my ELB. And it is in the VPC, and it is allowing the port 80 and which subnets. You see, I2A and this is the public subnet, right? This is what my instances are running to a. So I added this one, and this one also my instance is running. So I'll add this one. So I'll add, you see, selected subnet 2A, US is 2A and 2B, and the subnets. Availability zone, 2 separate availability zones, 2 separate subnets. IP addresses, this is 0 and this is 20, and security group add, and I add a security group which allows port 80, and something here called health check. Okay, so here, this is what I think I said last time. I'll explain. So first of all, load balancer works with a health check concept. Like it will send the traffic only when it finds that the instance is healthy. So how it will do is, first it will check according to a path. Like you can give any path, and you can create new file and call maybe healthy, and you can send a message. So it will always check this index file if it is available in the web server or not. If it's only find that it get a response from this file that yes, index.html is available for the serving publicly or at the port 80, then only it will send the traffic. Otherwise, it will not. Okay, so it's important. So, and you see, these are the advanced details: response timeout, time to wait when receiving a response from the health check. That means here 5 seconds, it will wait for 5 seconds to check if I get, I'll reduce it to 2, just 2 seconds. It means in the 2 seconds, if you can have up to 60 seconds also, by the way. So I quickly have to check within 2 seconds, if I don't receive health signal or response, and interval also, instead of 30, maybe I'll give 3 seconds in every, okay, 5 seconds. So it is minimum is 5. So in 5 seconds interval, I'll keep sending another one. Suppose first one is failure, right? Then after 5 seconds, I'll send another health check signal. And on unhealthy threshold, this is number of times, if you see here, number of consecutive health check failures. That means I declare it, suppose 3. That means if I get consecutively 3 failures, then the ELB will declare the instance as a failed instance. That means the instance has been failed or it is unable to service any request. So it will notify that instance as not working. And healthy threshold is, suppose I want to put it maybe 4. That means if it will obviously send every timeout is 2, 5 minutes, 5 second interval, it is going to be 4 threshold, like 4 consecutively, 4 checks it will do. And if you get 4, then it will declare that instance is healthy. Let's have this set up quickly. And then add the instances. So I'll add both the instances. And add tags, I'll name it. And I'll call it web ELB, web server, web server. Review and create. So here everything seems right, and create. So successfully created the load balancer. So so according to discussion, you see the stickiness I discussed just previously, right? Session stickiness, you can always enable from here. Edit stickiness, and you can enable and you can disable. I'll discuss a bit more on that. Instances, and you see here, when you go to instances, these are the 2 instances we created, web server 1 and web server 2. So here still it's showing out of service. That means it is still not ready. The ELB is still not ready to serve the instances. So if you go here, description, you will not get any IP address of the ELB actually. You will be always getting the DNS name of the ELB. So remember this. You will not get any IP address of the ELB, but you will get only DNS name. You see, still it is not ready, so you will not get it. So let's see when this instances will be okay now in service. So hopefully, yeah, we got it. So here now it is serving web server 2. If you just refresh, keep refreshing, you know, 1, 2, 1, 2, right? I just keep refreshing it. So sometimes we are getting 1, sometimes we are getting 2. You saw it? So that means actually it is serving both the server at a time. And based on the traffic, alternately it is serving 50% traffic is served by the ELB, load balancer, which is classic load balancer. So this is the demo of how both the instances are attached to the load balancer, right? So now just to check the high availability, that means if 2 are there, suppose 2 are the same instances, previously what I said, it solves, not only it is load balancing now, you saw that it is load balancing, but also suppose I am going to stop one instance. Let's stop one instance purposefully, just to, obviously, you know that as it says that if I just stop it, if I stop the instance, right? So stopping now, every time you will get only 2. That means it is all the traffic is going to 2. That means if both the instances are same, suppose, I'll tell you also how to make both instances same, exactly the same, okay? Then if one instance goes down, other instance is always working. So that is also one demo of highly available instance. That means our instances, our application is always on. Even if one instance goes down. So in fact, same thing you can create by 3 ELB, like 3 availability zones, edges. So if one availability zone complete goes down, it can still serve by another 2 availability zone. So if 2 availability zones are going down, then still it can be solved with the 3rd availability zone. So this is common exam question that if you want to have one instance of like shared by 3 availability zones, how many instances you want to have? Suppose you want to have 6 instances. Let's take an example. Suppose you want to have 6 instances, okay? Or to at least, okay, let's put this way. At least 2 instances should be on always of a particular application. Based on your architecture, you need at least 2 instances should be always on, irrespective of what, okay? No matter what, no matter how many failures, you want always 2 instances should be running. And you have to use 3 availability zones, right? So how many instances you need to create? So let's see the scenarios. Suppose you said 3. So I created 3 availability zones and 3, that means 9 instances always running. Suppose 2 are going down, right? Then still you have minimum 3 instances are running and 2 instances anyway you have the requirement. Suppose let's see 6. Let's see 6. Suppose you want to run 6 instances, 2 in each availability zone, right? So even if 2 availability zones goes down, still you have 2 also. So then why 9? Why 3? Suppose I have 2 availability zones running, okay? Then I want to have 2. Then if 1 goes down, then if 2 goes down, then I'll have none, right? So another thing is, sometimes your traffic, this is based on the availability zones and the based on the availability of the application. Suppose you want to have traffic also should be served by like you need 4 instances to be served always. That means you want 25% of your traffic should be, the max should be served by 1 instance, right? 25%. And you need then minimum 4 instances to be served always, right? And then how many, based on your, suppose you have 4, based on your architecture, how many availability zones you want to have? If you want to use all the 3, there's another way. So that means you want 25% max should be used up for the each instance. Suppose 2 instances goes down, right? Then you need to have 4 running. So 4 instances in each availability zone. Suppose you have 1 failure, then you may have 2 and 2 in 2 availability zones, 25%, so 50-50. Suppose you want whole thing to be gone, you want to have your architecture should be fail safe of 2 availability zones, then at least you should run how many instances? 12 instances. Did you get that? That means your fail safe should be, your application should be fail safe for 2 availability zone failure. That means but you want 4 instances should be always running, 25% each. So that means minimum you need 4 instances to be running. So you have in 1 availability zone all the 4 instances. And if you want to have 3 availability zones, then at least you need 12 instances to be running all the time. And because you want and this is you can say that is a wastage of resource, but it comes with a price. Why? Your application should be always on. So according to your architecture, the cost will actually go down. Cost will really go high. Why? Instead of 4 instances, you are actually running, you have to run 12 instances. So because your requirement is stringent, you want 99.99999% of availability, right? The SLA is quite high. Then you need to obviously run that many instances, because even if 2 availability zone goes down, your applications should not suffer. And these are all normal architecture, which is a mission critical applications or user your main business applications. You don't want even if a single minute user should be suffering. That type of architecture, you take multi-availability zone failure into account. So you run almost 3 times of instances what you need to run. Okay, so let's go back and I'll start again. And you can have only 1 availability zone's failure. If you want to withstand, you need to run only 8. If you want to pour 25%. So, but it cannot withstand 2 availability. That means your architecture cannot, if you are running 8, suppose 4 and 4, then your architecture cannot withstand 2 it can only withstand 1 availability zone failure. It cannot withstand 2 availability zone failure. But that will be very rare. If Amazon 2 availability zones failure is quite rare, but still they give that option. Okay, so this is what the ELB classic. Let's see the application load balancer. So I'll delete it and create another availability load balancer of application load balancer. So create it, and my ALB application load balancer, and it is internet facing. There can be internal also. I'll tell you that later. So this is IPv4 and listener is 80 and availability zone is 2A and 2B and subnet is public. And security settings, configure, and I have only existing security group. Routing, you see here there is a difference. Configure routing, right? Here it is not instance, it can be instance, but it asks a group of instances, not just one instance. So you have to add a new target group rather than particular instance. So I call it my web page group. Okay, and it is target group. So is it, you can have IP based and you can have instance based. IP based, when you choose is if you have another separate IP instances somewhere else running and you want some traffic to be shared there also, other than even if AWS instance, because you have a public IP and you want to add that into a load balancer. There you can select IP based target group. Suppose some instances are in other cloud maybe or in-house. So you can create a group of in-house instances and I add all those publicly available IPs for them and you can create a group of instances there. And here, I want to just point a note here, path. So this is for health check. Again, index.html should be checked, okay? And I will, by default, maybe I want to keep the same or just to, because this is not, and I want to keep interval as maybe 5, okay? And maybe timeout is 4, registered targets, and I want to keep, I am to add these 2 instances to the targets and review and create, right? Listeners, you see here listeners. So how it is different is, this you will not find in the classic load balancer. Here you can actually, you can have multiple rules, custom rules you can have it here. You see, I will not go details about this, possibly you can read it with some documents. Okay, this is, it will take a lot of time because there are a lot of rules you can set here and that will be honored if you have some rules here. Whereas this particular page rules you cannot set with the classic load balancer. But with application load balancer, you can have multiple rules set. Okay, and you can see, you can insert rule and so on and so forth. So that's the one difference. And let's see, description, listeners, my group, targets. Okay, there are targets here. We have to add the edit the targets and save. Oh, sorry, it didn't add it actually. So here add to register and save. Okay. Now it will take some time. It is start as initial, it should come as ready. Okay. So now if you go to the load balancer, and my ALB, if you go to the DNS name and put it, okay, it is ready almost. Then it's ready. Okay, my ALB. So here, 2, right? It is serving now. So it is hopefully the listener group targets. Yes, healthy. That's right. So it is the load balancer normally used, and you can similar way you can create a load balancer with network load balancer, but that will be not needed because you mostly all your requirement will be, because this will be created only when you want ultra high latency, ultra low latency and kind of your traffic is really quite high and you don't want to have a application layer routing, rather you want to have a network layer level of routing, that time you need to create this network load balancer. So that's all for today. And I'll also show, okay, if you want to have a similar web server, same, I had here two, right? So I want to have the same instance. So what I'll do is, and let me delete it, instances terminate, okay? So I'm terminating web server 2 and I'm stopping, and I'll stop the other one. Web server 1, I'll stop it. So what I'm going to do is, I'm deleting 1, that means, and let it be stopped. So it is still stopping and web server 2 is terminated. It is no more available. Okay, it stopped. Okay, now how to have same instances in two availability zone? Exactly the same to serve the traffic, same data, same session, right? So all instances need to be same. So in two availability zones, so how to do is, web server 1, I'll do action image. You see here, so I'll select it, web server 1, go to action, go to image and create an image from the instance. So instance ID, okay, this one instance ID, and I'll create my master image, master web server image. I named it so that this will serve as kind of template, okay, and I call it master template of the web server, and I take the root and I create an image. So now it is started creation of an image. Here, how to see the image? Go to images and AMIs, Amazon Machine Images, Amazon Machine Images. You see this is getting created, right? So let's wait for some time. It will take some time to be created. Though it is 8 gig, it should be fairly fast. It's not a big image. Still pending. So what I'll do is I'll create this machine image and I'll launch another instance from this image, rather than when previously what I used to do is when I created the instance, I was taking this image, right? This is the image. But now I'll not choose this image. I'll choose my own image. Okay, because it's already created from one instance. That means the code and the file, everything will be there. It will be the same index. Okay, now it is available. Okay, so my master web server image. So go to running instances. Now I can even, in fact, let's start it. The one is started, that means it's the same. Let's start another one, launch another instance. But here I'll not launch the Amazon provided image. I have my image. Just click my image. You see here, master web server image, which I just created, it's available now. And just select it and configure the same thing. And I'm going to run in my public subnet EB2. And I don't need to do anything here because it's already there. Okay. And this, let me have the public IP and storage, and give the storage add tags. And we name web server. There is nothing here, just web server, storage, then security group, and launch, right? Now, so what I'll do is, maybe instead of 1, I'll do, this is to A, and this is to B, right? Because it's running in 2B subnet, and this is 2A availability zone, this is 2B availability zone. So now 2B is running, and it has a public IP. Let's check it first, what it is. You see, same, web server 1. And this is also, you check 2A, this should be also web server 1. Right? Web server, both are web server 1. Right? And I have to obviously now load balancing again, load balancer. I'll go listeners, group, and group targets. You see, this is availability zone to A and edit. So I have to just add both and save. So one is healthy, another is, but now if I quickly go just to check, still it should work, though one is not, sorry. The load balancer, and this is the load balancer. I'll go there and check it. Server 1, it will be always server 1. Okay, and because here if you see listeners and the target, now both are healthy. Even if I delete one instance as I did previously, it will be always the observer 1. That means it is the same application is running in the 2 separate availability zone. So, and I can enable the sticky sessions also here. That means now 2 separate availability zones, 2 separate instances, right? So here I can, here in application load balancer, the sticky session was to a target group rather than instance. Okay, so here we can enable the sticky session disable. If you edit attribute and you enable, what will happen is you can actually sticky session duration, you can maybe it's 5 minutes, it should disable, and now it is enabled. So, and here it is, the sticky session is respect to the group rather than an instance. That is the difference. So here with the load classic load balancer, the sticky sessions are with instances, whereas in modern application load balancer, these sticky sessions are related to the target group. So I'll disable it. Okay. That's all I had today to show. And okay, by the way, if you're not using your instances and images, I advise to delete it immediately.
Just now I did, Panchaleshwar. I just deleted everything.
So terminate rather than stop, terminate. Okay. And also what I'm going to do is, my image also, it is taking some, it is obviously taking the space. So I'll delete that also. Okay. Deregister first, and it is deleted once you deregister. So my EMI is, if you see, nothing. Okay. And obviously, is there any, don't forget to remove your load balancer. They are chargeable. Okay. So delete it. Don't keep your load balancer running. You'll get a bill. So target groups also delete it. Okay. So nothing. So next we have, today we learned about the instances and how the traffic is divided. And we learned about different types of load balancers, classic load balancer, application load balancer, and network load balancer. Then we learn about for the sticky sessions, how it should be enabled and how the traffic cross-load balancing is enabled. And we also know route-based traffic, how it can be enabled. So with that, my session is ending today. I have some, okay. So any doubts? And next session, we learn about the auto scaling group, how to create auto scaling. Today we saw part of the resilient architecture, high availability we saw, but we didn't see about how scale dynamically computing, increasing the compute resource on demand dynamically. You don't have to do anything. If you create auto scaling group, how it can be scaled automatically based on your demand. That we'll see in the next session. Okay, hopefully everybody understood, and we'll stop today here because we have to go with the kids for our birthday.
Enjoy.
Enjoy your
Thanks.
birthday.
Thank you. Thank
Oh,
you.
enjoy, friends. Thank you.
Oh, good
Thank
time.
you.
Sir. Okay, bye.
Bye.